Okay, so here we have a three-body Newton's second law question. A truck pulls two trailers, find the acceleration and the tension of each chain. So here we have a truck, it's got a mass of 600 kilograms, and we have two trailers, one's 400 and one's 300 kilograms. We're assuming there's no friction in this situation, and the truck is being pulled forward by a force of 2,000 newtons, which would obviously be coming from the engine. So the first thing we're going to do is find the acceleration of the entire system. What I'm going to do is model this as a single block, adding up all these masses and incorporating this force. So we have, that's 1,300 kilograms being pulled by 2,000 newtons. So here our net force is 2,000. Our mass is 1,300 kilograms. So our acceleration by Newton's second law is the net force divided by the mass. So that's 2,000 divided by 1,300. So our acceleration is 1.54. And because that's newtons and that's kilograms, that's 1.54 meters per second squared. So this entire system is going to accelerate at the same rate. The entire system will accelerate at 1.54 meters per second squared. The acceleration is the same because they're all held together by chains. Now we need to find the tension of each chain. So if I redraw my original diagram just as simple blocks, this is 300 kilograms, 400 kilograms, and 600 kilograms. This has 2,000 newtons pulling. And we don't know this tension. I'm going to call that T1, and I'm going to call this T2. And I'm going to start at the back here. We've got 300 kilograms being pulled forward by T2. And we know the acceleration to be 1.54 meters per second squared. Remember, we found the acceleration by standing back, considering the whole system as a single block, taking its total mass and the total net force acting upon it. So given this acceleration and this mass, Newton's second law is force is equal to mass times acceleration. So that makes our tension T2 equal to 1.54 times 300. So the tension is 462 newtons. That's our tension here. I'm now going to consider the middle block. A free body diagram of the middle block. It has a mass of 400 kilograms. It has tension T2 pulling it back. So this is an action-reaction pair of forces. Via that chain, the mid-trailer pulls the back trailer forward with force 462 newtons. The back trailer pulls back on the mid-trailer with an equal magnitude force in the opposite direction. And all of that is expressed as the tension T2. So T2 is 462 newtons pulling the middle block back. T1, and let me just show you this diagram again. T1 is the tension in this chain, which is pulling the middle block forward. And with all of that together, the net force is equal to negative 462, because if our net force is considered forward, this is going to be a negative as it's pulling back, plus T1. T1 being the tension in the cable between the truck and the middle trailer. We also know that our net force is mass times acceleration, which makes it 400 kilograms times that same acceleration, 1.54 meters per second squared. So the net force on the middle block is 400 kilograms times 1.54, 616 newtons. Now looking back here, our net force is 616 newtons. So 616 newtons is equal to minus 462 plus T1. So just a little bit of rearranging. Remember that was negative. Our net force was negative 462 because it's going to the left, plus T1, which is going to the right. So a little bit of rearranging, and T1 is equal to 616 plus 462. So that is 1,700. No, sorry, that's 1,078. Let me double check. Yeah. So tension T1 is 1,078. So going back to our original diagram, we were originally given this system here. It will accelerate forward with an acceleration of 1.54 meters per second squared. And the tension here, T1, is equal to 1,078 newtons. And the tension here, T2, is equal to 462 newtons. Now notice we can look at the whole system as a single block and it'll obey Newton's second law. We can look at the subcomponents of the system as individual blocks, and via free body diagram on each of them, they all also obey Newton's second law.